All right, well, since the last time we spoke, I've done a little bit of decorating and fancy schmanciness on the chassis. Painted it black for the rust coating, and then over top of that I painted it this really nice hammered black effect with this hammered black paint, which I really like. I might do that to all my chassis. And then of course I put the blood splatter, which it's a little much. Yes, I agree. That's a little much on the blood splatter. But there you go. And also, I made the overbridge. So this piece is done too. Did it the same way. Got the hammered and the blood splatter. Cut out my holes on the side. I had to make a notch here for the, well, same as this notch here. And then that'll live on here like this, see? And then when this whole thing is up inside the chassis, it'll look like that. And all my, of course, my transformers go down here. In fact, here, let me set that up real quick. So pretty much just like this. So of course, it'll be inside the chassis. I'll have my filter board right here, which I haven't drilled any holes for yet because I haven't built the board yet. I'm going to have another little tag board right about in here somewhere. Volume, tone, input jack. And one other thing I'm going to put right here is the dark mark, because it's a Voldemort amp. Whoops, I said the thing. It's a Dark Lord amp. I haven't figured out which one I'm going to put on here yet. These are the more fancy ones, but I'm also kind of digging this one right here in the middle, this kind of cartoonish looking one. It's very simple, and it's, I don't know, something about it, I like it. I got 3.5 inches from here to here, and these are just under 3.5. This is more like 3.25, maybe a little less. And these are, this is sticker paper. This is a sticker. But I'm not going to rely on the adhesive that's on the back of this. I'm also going to spray this with some spray-on adhesive, let it dry, probably hit it again, let it dry, and then peel this off and stick it on. Now I'm going to take an X-Acto knife, whichever one of these I choose, and I'm going to carve it as close to this edge around here as I can, including all these cutouts in between, and then I'll put it on there. But a lot more decorations to do on the chassis before I get to the actual components. The component part, oddly, strangely enough, is the easy part. I still have to make the board. Whoops. Still have to make the board. You can see I got a little cutout here for my notch for the wires to poke through. But I'll make the board, and then I'll get I'll keep moving on this. So this is where I'm at so far. Now, one thing I need to emphasize here is that even though this has a fancy paint job, right here and at all of these corners here and underneath, I scraped away enough of the bridge here. I scraped enough metal away so that I'll have metal to metal contact, because I'm going to need a good ground from all my components and whatnot up here for the chassis. And then my power cord is actually going to end up getting grounded right here to this bolt. So this really does have to have good, solid, clean metal to metal contact. So scrape away any paint or anything you have that might act as an insulator and get metal to metal. So I went down to Skycraft, my favorite surplus store, and I was able to get some of these aluminum standoffs. And with that, I was able to build up my tube guards here. So I'm about to paint these black. Well, it's a beautiful spring day here in Central Florida, and literally not a cloud in the sky. Absolutely gorgeous. And I'm out here Working on the board. This is a piece of Garolite, which you can get at Granger, or you can even order it on Amazon. This is a little more than about 1/8 of an inch thick, and it's a good size to fit my eyelets. And then this is a scale drawing of the board that I'm going to make for the power filter. So I've got all my components on here, where I want to lay them out, and this is actual size. I drew it up in CAD, printed it in real life size. So there's my dimensions, and what I'm going to do is I'm going to cut this out. Well, I'm going to cut this right at 2 1/4 by 4 1/2, and then I'm going to cut this out on a piece of paper, and using some sticky spray, I'm going to spritz it on here, stick it over the top, and then this will show me exactly where I need to drill my holes and what size. So I'm going to spare you the tedious part of me cutting this, and I'll show you the end result here. And here we are. Actually overshot the mark a little bit, but it's all right. Put a little arrow on there to remind me which end is up. And I'm going to mark the back here, saying this is back. I'm going to go ahead and drill these holes. I like using Garolite rather than MDF. This is much heavier than MDF. And it's also electrically more insulating. You don't get crosstalk between the holes. So that's always a good thing. All right, I'm going to drill. My favorite surplus store has quite a lot of eyelets, and I'm actually going to go back there and buy some more here shortly, but I'm going to be using these. The thickness is about 1/8 of an inch, and the hole is about 1/8 of an inch. And then I will use my homemade eyelet setting tool. It works. All right, got the holes drilled. These holes here, this one, and the 2 on the outside over here. These are for mounting. Everything else is for components. All right, and there you go. There's my completed board ready to be populated. Now, let's talk about what's actually going on here. All right, so right here you have your 3 filter stages. It's actually 4. So you've got your bridge rectifier coming in, your HT coming off of the power transformer is going to land right here, and that'll give me about 290 volts AC. Once it goes through the rectification and goes through this first filter stage, this being the negative, I'll have somewhere in the 320 volt DC range. Once I have a load on it, it'd be 320 volts or so. And then that's my first filter stage, and then it goes through a dropping resistor because I want about 300 on the plates. It says 24K here, but that's for a different power transformer. I know that I'm going to need about 3K here. I'll look it up once I get to it, but a dropping resistor at any rate. And then it goes to the second gain filter stage here that runs off to the output transformer primary. Goes through a dropping resistor to another filter stage. This side runs off to the screen, and then it runs through another dropping resistor, and then this filter here runs off to all the preamp stuff. We're going to come off this third filter stage here for the screens, and this is the negative that's going to go to the screen side of things and the secondary of the output transformer, where the output jacks are. Isolate the output jacks from the chassis and give it its own signal ground right here. And then this ground is going to be run for all the preamp tubes. Well, it's only one tube, 2 triodes. Now over here, where things get a little bit trickier in a sense, you've got your heater 6.3 volt coming in to this side of the resistor, and then going right back out again, and then going into this side of the resistor and right back out again. So it's isolated from this resistor, and this feeds the heaters. So that'll just run off to the tube heaters. However, on this side, what's actually going through the resistor is for the pilot light. It needs a current limiting resistor, so I've got 100 ohm at 1/4 watt. So I got 6.3 coming in. I'll have 6 or so coming out to feed the pilot light. And that's it. That's the whole filter stage right there. So I'm about to go build that up and get it ready. All right, so before we mount this or build it up, I have to figure out where is it actually going to live on here. So the way to do that is you take your bridge here and you line these holes up. And you take your special scratching tool and you scratch along the edge. Do that on both sides. And that'll show you where the edge of this lip is, and then you come in from that a little ways, you know, whatever. And that way this will live out here somewhere. You can figure all that out. So let's do that. All right, I know it's a little hard to see, but you've got two black dots there, two black dots over here. Those are my holes. This edge of the tape here is the edge of my board, so it'll live like that. And then I have another dot right here because I have this tag board that I need to put on. That's going to be for my frameless mid scoop. That'll live somewhere in that area. This lug here has to go here and here. So let's keep it on this side. This lug has to go that way. So that's why we're facing it this direction and not that direction. I also had to make sure that where that hole is doesn't interfere with the power transformer or the output transformer that's living right underneath it, and it doesn't. It clears. A lot of things you got to look at when you're working in a small confined space like this. It's really tight. Another thing I have to do is these three holes here, I have to make sure that they have good ground. So I need to take some of the paint off the edge here. So I'm just going to go drill holes and scratch away paint and make sure this is all ready to go. So I'm just going to go do that. All right, so what you see me here doing is installing the diodes for the bridge rectifier. These are 1N4007 diodes. They're good, rated at 1 amp and good for 1000 forward volts. Now this circuit I'm building isn't going to be drawing anywhere near that, so we're well within the safety range for these diodes, and they're cheap, so yeah, why not use them. Just to briefly explain here what a diode does. A diode passes an AC voltage in one direction only, meaning it passes either the positive lobe of the AC waveform or it passes the negative lobe of the AC waveform, depending on which way you have it oriented. It only does one half of the waveform at a time, which means I need to kind of explain, if you don't understand that, what AC actually is. Your wall voltage is at 120 volts at 60 hertz. Now what that means is it goes from 0 volts to 120 volts positive, back down to 0 volts, and then it goes 120 volts negative, back up to 0 volts. That is one waveform, and that happens 60 times per second. That's your wall voltage. What the rectifier does with this bunch of diodes I have in here, when you point them in the right direction, is it takes that entire negative lobe of the AC form and flips it positive. So there's no longer anything passing below 0 volts. It doesn't go negative. It all stays positive. So now it goes from 0 to 120 volts to 0, back up to 120 volts positive to 0, back up to 120 volts positive to 0. And it does that. That is technically a DC waveform because it's only on one side of the negative of the 0 line. But it's got an awful lot of ripple in it, and we can't have that. So we need to smooth that out so that it is absolutely dead flat at 120 volts or whatever, positive, no ripple in it. And that's what all of these capacitors and resistors that I'm putting in here do. the capacitors store energy and release it at a certain rate. The resistors resist, which helps kind of compress the waveform in an odd kind of a way. It's hard else to explain it. And so by the time you get to the preamp stage, there is dead zero, no ripple whatsoever. And so none of that ripple is getting amplified by the time it gets to the power tube stage. And so that's what this whole board is all about. It's just filtering the DC coming off the power transformer and the diodes. Now you'll see here a little bit earlier I had a little spacer up underneath some of these resistors. These dropping resistors can get warm. They're rated at 1 watt, 2 watts, but they can still get a little bit warm, and so it's just a safety precaution to lift that off the board so it doesn't burn the board. And that's all that is. So here's me building this thing, and I'm attaching these whips and these leads on here to, I'm going to steer the ground where they need to go rather than just trying to rely on a ground is ground kind of a motif, which ground is not ground. I mean, it is, but you know, when you're dealing with tube amps and there are certain sections within the circuit, you want to be able to steer the ground for that circuit back to where it came from. And so that's why I have these extra long leads on here coming off the negative side of these caps. Positive side feeds the positive side of the plates for each one of these tubes. And that's pretty much what this is all about. So yeah, sit here and watch a silent film for a little bit. All right, so we're going to talk about the power transformer. This is a Hammond 229 series low profile PC board mount power supply. And I got it for 2 reasons. One, it's small. As you know, working in a lunchbox is pretty cramped space, and I don't have the room for a more traditional power supply, say something like this, although this will fit too, but and it's got just enough power voltage ratings that I'm looking for. 120 on the primary, 230 volts on the secondary at 50 milliamps. Well, my entire circuit only draws about 10 to 12 milliamps. So that secondary voltage is going to go up a lot higher. And as you see, after rectification, it will be somewhere in the 320 volt range. So this is a pretty cool little power transformer. But it does take a slight amount of modification in order to make it work the way I want it to. So that's where this cheat sheet comes in. So the primary can be wired either 115 or 230 volts. We're in the United States, we're going to come in at 115. So I'm going to wire the primary, which is your wall voltage, in parallel. So I need to wire my connections like this. So I need to make certain amount of jumpers so that they match this. On the secondary, however, if I want 50 milliamps at 230 volts, that secondary has to be wired in series. And that would be wiring the output like this, which is another series of jumpers and weirdo things. Now, in order to make that happen, two things need to be done. I need to transfer these numbers that correlate with these pin numbers here to the other side where I can see them, because these are my connection points. So that's the first thing I'm going to do. So it's 1, 2, 4, 3 on the bottom here. So it's 1, make sure I get this right. 1, 2, 4, 3. So 1, 2, 4, 3. And over here, 7, 8, 6, 5. Do it this way. Make sure I got it right. 7, 8, 6, 5. 7, 8, 6. Yep. Now, I'm going to take my needle nose and make little hooks on here. So I got some place to jumper my wires to. I don't want to just solder onto a point. I'm going to make a little hook so it's a much more secure connection. So, now, on the primary here, I'm going to use heavier wire. I've got, what did I do with it? Got some 18 gauge here, so I'm going to use the black. White is reserved for neutral in electrical wiring, so I'll use black as hot, because in electrical wiring, black is hot. In the audio world, it's usually the other way around. This would be your ground, and or the second neutral, whatever, the other, and white hot, so it'd be white hot, but that's not how it is in the house wiring world. So this is kind of what we're doing here, is house wiring kind of thing. So I'm going to use black to make my jumpers. So I'm just going to peel off a little bit of that, and I'm going to make it up so I'm jumpering from 3 to 1 and from 4 to 2. 3 to 1, 4 to 2. Yeah, again, I need to keep this somewhat clean because I got my main primary coming in to one or the other of these pins. Probably keep it on 2. So when I bring my main power cord in, I'm going to land it at pins 1 and either one of these. So 1 and 2 will get that, and then this is here. So these are jumpered in parallel. Now the output needs to be in series. So I'm going to make these jumpers 5 and 8, and then leave these 2 alone. Well, I'll put leads on here because these 2 leads will feed up to my rectifier. So, and I'm color coding it. Everything here on this side is going to be in red. So I've got my mains coming in here in one color, and my secondary coming out is all going to be red for high power, which in the amp world is called HT, high tension. And once it hits the rectifier, it becomes B+. All these funny names. All right, at this point, I'm going to tag a couple of leads on here that will feed up to my rectifier. The screws I have, the heads won't, you'll see this hole is right smack next to this piece of plastic. I mean, it's literally right at the edge. So in order to put a screw on it, I don't have enough room here with this plastic in the way to get the head all the way down. So what I do is I take a drill bit and I just ream out just a little bit of this plastic on either side. And then I can get a head on here for a screw, and I'm going to bolt it up to a spacer that's on this side here. And then when I line it up over the holes in the bottom of my chassis, all I got to do is pop the screws up from underneath. So this whole piece goes in as one big unit with the spacers already attached to it. So I'm going to go ahead and do that now. I know that looks scary. And I might have to do it again, but I'm not really hurting anything so long as I don't go too deep into the plastic or too far to one side or the other. The first time I did that, you'll see how this has got plenty of room, but this has this plastic tab for these connection points up here. Wish I could mount it that way, but I really can't. I mean, that's where all the power is, and if that doesn't clear, if it's something to touch, that's just too scary to mount it this direction. So that's why I do it the way I do. I'm going to go this way, but I'm going to have to take a little more off of there. Tell you what, let me go outside and get a better set of drill bits, and I'll do that, and then I'll show you where I'm at when I'm done. Alright, so as you can see, I got a little scallop here on either side. And I did nick the wire right here a little bit, so, you know, I probably should have done that before I soldered anything. But luckily, I've got plenty of leads, so I'm going to pull this one off, strip it back to there, resolder it, and then this thing is mostly ready to go. Hold on, let me just do that real quick. All right, and with that, my stash of nylon standoffs, and I'm going to use these number 6 quarter-inch hexagons. They're going to be just tall enough. Can you see that? To clear the bottom up by just a little bit. That's all I need. If I don't drop it. Again, I got all these down at Skycraft. Best surplus store in the world. Got a long bit here with a flathead on it. I don't need a lot of torque. I just need to get in there. And it just clears the bottom. So put that on there. I'm using nylon on here. That way I have no chance of this shorting out to the chassis whatsoever. And when I bolt it to the bottom, I'm going to use a nylon screw to hold it in. That way it's all good. All right, one more thing I'm going to show here before we wrap this portion up. I'm going to wrap these up in a tight twist, which will keep the noise down. And I do that with a drill. So I'll take the ends of these, put them in my drill, Now the last thing I like to do before I take it out of there just put a little bit of heat on here and it'll keep that twist. If you take it off too soon without doing this, a lot of times it'll untwist. Not by a lot, but you know, if you're going to twist it, keep the noise down, then twist it. So give that a second or two to set in, cool down, and then there you go. And that'll stay there. Good. Now, eventually, these two leads are going to fish around the top bridge piece here, and they're going to land here and here. And I may or may not fish it through this way underneath. I may go around it. Fishing through would be all right, I think, but it may also end up being a little bit difficult. I got to get one here and the other one goes there. They both won't be going under, but eventually it's actually going to live on top of each other pretty much right like that. $120 coming in. What did I say? Right here. 230, 290-ish coming out right here. Once it lands here, it goes through the rectification and the filtering, and I get to this point, which is where I'm going to take my feed. It'll be, well, to this point, it'll be 320 volts. By the time I get over here, it'll be right around 300, maybe a little less. I'm shooting for 300 or a little less. That's really where I want it. And there you go.